Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the GRI number 199-12. This is what we would call a door position switch, and it's very simply comprised of two parts. I would say you have here the frame portion with the wire leads. I say that because it'd probably be more practical to run wires through or to the frame rather than through the door if all you have is a door position switch installed. If you already have wires going into the door, then by all means. Otherwise, likely the frame portion, then the opposite portion. Okay, and this is a double pull, double throw switch, and we're going to go over that at length. So the 199-12, that in essence it means that it is a 1-inch size unit. This is going to have an electrical configuration of double pull, double throw, and is the BLK or black. Okay, is what this is, or the 199-12 means all of that. Okay, 12-inch, 22 gauge, 22 wire gauge leads. There will be a total of 6 wires, and that's because you have a double pull, double throw. That would only be, as far as I know, 6 wires. So anyway, it's 6 wires. The outside diameter of the face is about 1 3/16 inches. This is going to snap or push into a 1-inch hole that you've drilled in the door and frame. And a steel frame or an aluminum frame, this is really where this would be most appropriate. If you're doing wood, I'd probably say this wouldn't be appropriate, and you need to look for a different type that mechanically fastens to it. Very thin amount of material that's going to project off the face of the door and frame and won't cause any sort of trouble with your door clearance. Let's talk specifically about where you're going to use a double pull, double throw switch. So a double pull, double throw switch, that means that, as we said, you'll have 6 wires. 2 of them are going to be common, 2 of them are going to be normally closed, and 2 of them will be normally opened. And basically what that means is there are 2 circuits that you can run here. The factory twists a white, red, and green together because there are 2 white, 2 red, 2 green, and they're saying that this is one circuit, or a common and a normally open and a normally closed. The question is I don't know what these wires are. By looking at the colors, nowhere on the instructions does it tell you what the colors are. That's okay, it doesn't matter, and I'll show you why. Because if you're installing this material, certainly you're using a multimeter, and that's the tool that you'll use to very quickly determine what is what. The bottom line is you can have a open loop or a closed loop electrical configuration on a door position switch. Meaning, when the door is in its natural state, let's just assume that that's closed, that circuit can either be open or closed. Open is a fancy word of saying there's no power. Closed is a fancy way of saying there is power. Think of a drawbridge. When the drawbridge is closed, the cars can pass. When it's open, the cars can't pass. So you can have closed loop or open loop. That's pretty obvious what you're going to handle. It's just literally a light switch in a room. It's either open or closed. However, when you get into single pull double throw or double pull double throw, you'll always use the common. You'll grab the common wire. It will be one of the 2 wires, and then you'll grab either of the normally open or normally closed wires, which means you can either have a closed circuit here or a closed circuit here, or you can have an open circuit here or an open circuit here. So you can either have no power when the door is closed and then power when the door opens, or you can have power when the door is closed and no power when the door is opened, depending on what you're going to end up doing with it, is just the bottom line. And not to get ahead of ourselves too much, and just to back up a little bit, with a single pull double throw, you've got 3 wires. Common, normally open, normally closed. When you have a double pull double throw, it's just a second set of common, normally open, normally closed. A double pull, double throw is basically is only 2 single pull, double throws. Single pull, double throw versus closed loop, open loop basically means in closed loop or open loop, it's either this or it's this, meaning there is power in one configuration and no power, or there is no power and power. In a single pull, double throw, you can select what happens here and what happens here because you've got both of the wires that it takes to do that. What activates that, meaning your finger that hits the switch, this is the finger that hits the switch. It's either hitting the switch or it's not hitting the switch. In either instance, you are either turning on the light or you're turning off the light. And when this is brought within proximity, that is your finger hitting the switch up and down. That's all that it is. Now the question becomes is, why would you need that ability? Well, you may want... Well, it's obvious because, it's obvious in the sense that you may want a specific electrical configuration when the door is closed. Let's say that there is no power when the door is closed. The door opens, and those contacts leave each other, closing the circuit, allowing something like an annunciator to go off, a siren, a horn, a bell, maybe an indicator light. Maybe it turns on a piece of hardware or turns off a piece of hardware, or whatever it just simply might be. Or it could be writing back to access control, to a log, a computer system that's just logging an event. You might want, your system might require there be no power and then power, or power and then no power, or whatever it might be. The point being, though, is you can select that at the time of installation when you have a single pole double throw, or in this case, a double pull, double throw. Now what happens with these is you can have 2 things happen. Let's say there's no power that's happening. When that door opens, you can close the circuit, you can energize a horn, and you can then have an indicator light that occurs 100 feet away at a remote monitoring desk. You could do something like that. You could do, technically you can initiate an event that texts or calls someone. It can be really whatever, in the sense that all you're doing with this hardware is being able to report back to something, or to tell something else to do or to stop doing something when that is open or closed. So that is a beleaguered explanation of what this is, but because we're really only limited by imagination in terms of what we'd want to see happen with this, it's almost the best that I think I can come up with. Think of this. You have a Sally port or a man trap. When door A is opened, you want to make sure that door B is closed. Pardon me. When door A is opened, you want to make sure that door B is locked. So, no power. Door A opens. That then closes the circuit to door B, where the electromag locks. And vice versa, when door A is opened, you can then lock door B, such that you can get into one door and then you have to wait in a waiting area. You can't go further until the proper credentials or access is granted. So that could be, an indication. So a double pull, you could lock down that door, and then you can also notify the person monitoring the man trap that something occurring. Let's look and see. Let's figure out what wires are what. That's the fun part. Let's do that right now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, let's go over what we're dealing with here. So I have our switch. Our door position switch, our 2 sets of leads, our door and frame component, and of course I have here our multimeter. This is just a extremely inexpensive multimeter that I received for free, actually. It works perfectly. I have a much more expensive multimeter. This is the one that I constantly use. So I have it right now set to continuity. If you see a horn on your multimeter, That's continuity. And all that it's going to do when it sends continuity, or when you're checking for continuity, is when I touch the probes, you'll hear a sound, and that tells me that there's continuity going through what we're working on. Meaning there is a closed circuit condition between the black probe, the red probe, and all the way through the machine. Okay? So there's a continuous path. And we're going to use this tool to check our wires in terms of what's common and what's normally open and what's normally closed. So in one condition, when I grab one of the wires, I'll get continuity in this condition, and when I introduce this, I will have no continuity. And then I will test the other wire in the same condition, and I'll be able to, by the process of elimination, figure out which is the common wire. So it sounds a lot harder than it actually is, so let's just start. I don't know what's common here. I have no idea. Well, I do have an idea because I work with these. So I'm going to select a wire that is probably not the common. So I'm going to, just for the sake of keeping something looking normal, or in terms of color coding, let's put red to red. Now, I'm going to take my black probe and I'm going to connect it to the green wire. There's no horn that's happening. There's no sound. I'm going to hold these two together. If I had alligator clips, this would be easier. And I'm going to introduce what's probably the door portion. I get no sound at all. So I'm either not making contact, but I know that I am on my probes, or for sure what that means is neither of these wires, the red or the green, are the common. Because if one of them was the common, I would get a horn here or here. So let's drop off the green. Let's grab the white. So now white, we're getting sound. Let's introduce this. It turns off. Continuity? No continuity. Okay. So what we can do now is let's drop the red and grab the green. So the opposite should happen. When the two parts are separated, I should not hear a sound at all. And when I bring this to here, I should get a sound. And I do. So in two steps, we realized white must be common, and the green wire is such that the circuit's probably going to be normally closed, in the sense that I get power, no power here, and I get power here. Open circuit, closed circuit. With the white wire and the red wire, I got closed circuit here, open circuit here. That's how we figured out really, really quick which wire was which. And that's how you will do it as well, in the sense that you have, you could call the manufacturer and say which of these wires is common, normally open, and normally closed. But at the end of the day, if you're wiring this stuff, you have the tool, and wouldn't, of course, call the manufacturer for that information at all. Let's switch to the screen view and let's take a closer look at all of the supporting information. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, here is the item that we are looking at. Speaking of looking at, let's take a look at some images that we have. Here is the packaging, 199-12. That's what you get when you buy one. Looking at the back side, how the wires are coming out of the switch component itself. Showing the snap ring, there's two of them. An additional view, the face of it, and you'll see the 6 wires. Okay, now below this video is the extended description. Black, one-piece design, double pole, double throw. I know a Form C switch is a single pole, single throw. I don't recall a double pole, double throw. It might be Form CC. Yeah, I found an online reference that calls it a Form Z. You've got two throws, which is the common wire, well, actually, in a double pole switch is called a Form CC. I'm just not finding an easy correlation between Form CC and double pole, double throw. So let's just take a look at an image of what it would look like if it was drawn. Well, this would work. Yeah, because there are 6 terminals on this. Hopefully this shows us that image. Double pull, double throw toggle switch. Yeah, 6 terminals. Yeah, right here. 2 of these will be common. 2 will be normally open and 2 will be normally closed. It's the same sort of scenario. Okay. If it was going to be drawn, in absence of me quickly finding a drawing, we got a pole, like barber pole, and we got a throw. Okay, so you know, these switches can be like this, where they're connected here, or they can be connected here. But this is the common. Or they can be connected one like this and one like this. That's the beauty of this. You can connect it in any of these configurations, so that pole either goes to the normally closed or to the normally open. It's either always connected here, or or the opposite condition happens and it throws to the opposite. Let's move on. 1-inch diameter recessed mounting, self-locking, 12-inch 22 gauge leads, fire rated, lifetime warranty, switches and magnets available separately, options available, etc. Let's click on the document called template. This is more so a cut sheet. There's not really much to this. Recessed 3/4 and 1-inch steel door switch set. Okay. We're dealing with a 199. So the 199-12 is going to be double pull, double throw. We see that. That means it's a 1-inch diameter. Standard gap up to 1/2 inch, which means once you separate these pieces by more than 1/2 inch, you should get a change in state of what's happening. Now there's a table showing several different part numbers. 199-12 is down here. Yeah, read form. It's a CC, C times 2, or C by 2. So a Form CC switch. Gives you the maximum initial resistance in ohms, maximum voltage, maximum watts, what the contacts are rated for, then maximum amperage. You can allow a 1/4 amp running through this. On this table, you will find other electrical configurations. Closed loop type, open loop type, open or closed. And that's the heart of everything we've been discussing. You might call these open and or closed. Or open, close. Could be open, 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 closed, closed, open, times 2. Dimensional drawing of the material here. There are 3/4 inch and 1 inch listed here. Those are defined by these part numbers here. So if you wanted to do a double pull, double throw in a 3/4, it'd be a 195-12. Then you can do wide gap versions where you'll get 3/4 inch spacing between the items before you'd get a change in state. Okay, so that wraps up this door position switch. There is a link below this video as seen here to the manufacturer's page. And from here you can pull up not only all of the GRI or George Risk Industries items that we sell by means of this horizontal navigation.
AB Supply.
Also on this page is a link to the manufacturer's website, as well as a link to their full product catalog. If you're in the door hardware industry, you're going to very likely need not much beyond door position switches. These folks have 278 pages worth of componentry as it pertains to electrical work. If you have an overhead door and you look down and there's a big piece of silver that's been aluminum that's been put down to the floor for an overhead door, yeah, George Risk Industries. All kinds of stuff. They even have high security versions of these where the tolerance between the two magnets is very, very tiny and can detect a very small amount of separation between the two components. So you might want to scroll through here just to keep in the back of your head that someone has a lot of funny, interesting, I should say, electrical component solutions. But other than what we deal with on the routine, you're probably not going to use too much from these folks. Let's wrap up this video on camera. So if you have any questions on any George Risk Industries or GRI door position switches, please feel free to reach out to us. And keep in mind, they're very simple devices. What is the hardest thing to initially learn is what switch type do you need? Do you need open loop or closed loop, or do you need normally open or normally closed? And that's a deeper dive. You can search our YouTube channel for answers regarding fundamentals in low voltage electricity. Where certainly there will be videos where I talk specifically about those fundamental concepts. Any questions on the GRI 199-12 or any other GRI product, please feel free to reach out to us. And thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.